Welcome to Frankly Developing. I'm your host Frank, and today we want to take a deeper look into how source code reading influences our code writing as well. Last time we covered the basics of source code reading. If you haven't seen it yet, I've added a card at the top so you can go and watch that first. Having that basic understanding, we might go as far as asking ourselves an important question. How close should source code be to a best-selling book? Join me in finding out about the intricacies of this question. I'd appreciate it a lot if you could like the video and subscribe to the channel. Next, we'll look into various aspects of this question, and on the way, we'll cover more technical topics like DSLs and the builder pattern. First, let's get a few silly things out of the way. Of course, a book, or more particular books of prose, are usually read from front to back. We don't do that for source code at all. We jump from call to definition to declaration, from here to there, all the time when reading source code. So that cannot be what I mean here. Similarly, we don't want typical storytelling elements like character progression or suspense. And if you imagine you are trying to understand how a piece of code is controlling an engine to speed up the car, and you don't really appreciate a sudden plot twist in realizing that the code actually just uses the sound system to simulate the sound of speeding up. Yeah, those sound systems are a real thing, but surprises are not what we aim for in professional development. So what could we mean here? It's actually simpler if we dive into the book to the level of individual sentences. As humans, we are used to hearing and reading such sentences a lot. But take a look at this piece of testing code. Reading it doesn't work from left to right, but rather jumps around. Compare that to this variant of the same test and notice how it can easily be read from left to right. Let's see how we can make use of that for our own programs. Consider this piece of code, maybe it's for some game or simulation, in which you want to send a rocket with 3 astronauts to the moon. Yes, the comments look like prose, but it's still really hard to read. Even more so, if you optimized it like this. Let's first recap our reading levels from last time. Alphabet, tokens, expressions, semantics, and intentionality. Here's a perfect example for the typical lack of intentionality in our programs. We said we wanted the rocket to send 3 astronauts to the moon, but where in the code can you see that? You need to have this additional information available from somewhere outside to fully understand the code. Then you can, for example, relate the number 3 to the number of days it takes the rocket to reach the moon. If you still don't appreciate the problem, try to understand this piece of very similar code. What is the intention now? Even though it's just a trivial 3 lines, this is not at all easy to see. It's about time we bring in our idea of writing like a book. Here's another example variant. And notice how it supercharges your understanding of the code's intent. You can read it almost like a normal sentence. We want to plan a mission going to the destination moon, unmanned with 3, and returning back. Finally, the code provides us the necessary rocket for that mission. The advantages become much more apparent if you look at the second example in this style. Now it's much easier to see that this is an unmanned probe or satellite being sent to Mars. For those of you who may not yet know how to implement something like this, let's take a look under the cover. Let me know in the comments if you find this level of detail helpful or not. The basic implementation idea for such sentences is usually something you encounter when you first learn the builder pattern. I provide a link to the Wikipedia page in the description if you don't know that one yet. The idea is actually quite simple. Instead of creating the rocket object directly, we create a separate object responsible for creating the rocket. In our example, the plan a mission class is used for that. It can have its own private fields to keep track of important data, and it eventually provides a method to return an actual rocket object for us. Now you simply name all its methods so they make sense as a sentence when being called. And each method returns this, the very same configuration object for our mission. That's really all there is to it. No big magic or special language features needed. Of course, if your language provides more sophisticated means for creating so-called domain-specific languages or DSLs, by all means use those as well. You've seen how our understanding of reading levels, particularly that of intentionality, can support us in optimizing the readability of our programs. The really tough question now, however, is, should you do this? As a big advantage, readers can understand our intention much easier. Using such a pattern also allows us to reuse it in different code places, as we've seen for the Mars drone, which in turn helps us to keep the underlying configuration in sync. On the downside, however, we have a lot of additional code. Doing that for every single object certainly isn't going to pay off. Sometimes it can also be a problem that you're hiding too many details behind these fancy readable method names, and readers don't find what they were looking for initially. Also, without investing more effort, you could end up with really bad pieces of code like this. As with all such designs, it's largely a matter of experience to be able to select it at the right time and at the right place to really benefit from it. Go ahead and experiment with it. You'll quickly get a good feeling. For those cases, it is really helpful. Keep in mind that it's all about making our intentions explicit. Don't forget to like and subscribe. Thank you for watching and have fun developing.